Hi guys, welcome back to the new video on C++, and this is the model 7, and in this video we are going to talk about a very important topic in object-oriented programming, that is inheritance. So let us begin. In inheritance there are multiple forms. So the most basic one is a single inheritance. So in single inheritance we have one base class, okay, and then properties of this base class are inherited by a new class. We call that class as derived class. Okay, so these two important terms we need to remember. The class from where we are going to inherit data members or the properties. So that class is base class, and the class which is going to inherit those data members or properties, so that class is called as derived class. So we have two classes, A and B. So A is your base class and B is your derived class. So properties of A will be inherited by B. And then we have multiple inheritance, wherein we have multiple base classes, and properties or data members of these two base classes will be inherited via your derived class. So A and B are my two base classes, and C being my derived class. C is deriving properties or data members of class A and B. Then in case of hierarchical inheritance, we have single base class, and then properties of your base class A are inherited by these three different derived classes B, C, and D. And then in case of multiple inheritance, we have three classes. So this is your base class, and then this is your first derived class. So B is inheriting properties of A, and then we have another derived class. So C is deriving properties of B over here. So in a way, so C is inheriting properties of A via B. So in a way, it is inheriting properties of both A and B, but not directly, of course. And then we have a final type of inheritance form, that is hybrid inheritance. So we have one base class and other two derived classes which are inheriting properties of A, and then D is the third derived class which is inheriting properties of B and C. So in a way, properties of A are being derived via B and C. So this is one special case wherein a separate concept comes in, because A could be having, let's say, property small a. Okay, so small a will be inherited here and here as well. So to compiler, it can give one ambiguity, especially when D is going to derive properties of B and C. So there's no problem when it is going to derive individual properties of B and C. Let's say B, small b, and small c are properties of B and C. Because D is going to inherit B and C, and because B and C have already inherited A, so there would be a copy of A here and also here. Okay, so now when we are introducing D over here, so to compiler it will become a problematic case, because there is a clear ambiguity, because A is going to be repeated. So this special case is managed by a concept called as virtual base classes. So that is something that we'll check in detail once we finish our study on other types of forms, that is single inheritance, multiple inheritance, hierarchical inheritance, and multi-level. So let us see each of these forms one by one, and we are going to also check hybrid inheritance, but in a slightly different form. So when we talk about hybrid inheritance, that is it could be single inheritance combined with multiple inheritance, or multiple inheritance with hierarchical inheritance. So it can be a multi-form inheritance. That is why the name is hybrid inheritance. So before we start, we also need to understand the modes in which inheritance is done. Okay, so when you have your base class A and derived class B, So when this inheritance is going to be made, so this inheritance can be of mode public or private or protected. Okay, so let us check what effect it can bring to the derived class when the mode is specified as public. So these three are my mode of inheritance, and these are my type of member that will be inherited. Okay, so when we have a public member in your base class, okay, and your mode of inheritance is public, then the inherited member remains as public. Okay, then when the mode is selected as protected, the public member will become protected, and when the mode is selected as private, then the public member of the base class becomes private. And then, assuming that your base class has protected data members, and then in case of public mode of inheritance, the protected still remains as protected, and even protected as the mode of inheritance, protected member still will remain protected in your derived class. In the private mode, your protected members will become private. Now, the final case is in case you have private data members, then in public mode or in protected or in private, because this member is private, in all these three type of inheritance modes, uh, these variables cannot be inherited, or these data members cannot be inherited, because their basic scope was defined as the private. So that is the reason we use protected, especially when you are going to require to have your data members inherited to your derived class. So protected comes with a facility that your data member will be treated as private, but when you are going to use inheritance, those can be inherited in the derived classes. Okay, so that is one advantage. Now, one most important thing to understand over here is your protected members once inherited with the private mode, then those cannot be further inherited, because in the first level of inheritance those are going to become private. Okay, but in other cases like public and protected, those will continue to remain protected. So this was about types of modes inheritance. Now we'll talk about the derived classes. So how to derive a class? Okay. So in case of derived class, or when you want to inherit a class, so the syntax is you write class, then your derived class name, then you write your visibility mode. Okay, so visibility mode is something this. So you can have visibility mode as public, protected, and private, then your base class name. So suppose we have A and B as your two classes, A being the base class and B being the derived class. So in this case, we can write syntax as class B, which is your derived class, then colon, assuming now you're going to write visibility mode as public. So I'm writing public space your base class name, that is A, and then your definition of the class B starts. So this is the syntax, and just notice again here the semicolon over here. So here are two examples. So class car visibility mode as private, vehicle is the base class over here. So this becomes your derived class, this is your base class, and the visibility mode is private. So all the members which are part of your class vehicle will be inherited over here with the mode private. So your private members are anyways not going to inherit it. Your public and protected members, when those are going to get inherited in the class car, those will become private in this mode. And in the other example, we have public as the visibility mode. So again, the private members won't be inherited, but when protected are going to inherit, those will still remain as protected. Public will be inherited as is and will still remain as public members in the class car, which is your derived class. Now, this is a special case when you don't define any scope. So by default, we know that private will be the default one. So here, so you can assume this visibility mode as private over here. So that was one small point. Now we'll try to understand a single inheritance with the help of one example. So this is one example. We are going to use our class maths. It will have one private data member A. Now it is private because we are not mentioned private over here. Then we have public members over here. So int B is one public member, and then we have two functions, get val, which is not going to return anything. We are not passing any values to it either. And the other function is int get underscore A, to which again we are not passing any parameters. Then we have our derived class addition. Okay, then colon, visibility mode is public, and we are going to inherit the class maths. So in class addition, we are introducing one private variable, that is int c, and then under public we have two more functions, add and display. Both are again not returning any value, or we are not going to pass any parameters to these two functions. Now when this declaration is done, we are inheriting these members also. So A will be inherited in class addition. Now we are going to write the definition for get val function. So notice that we are writing it as maths colon colon get val. So this is the definition of get val function, and we are just going to initialize values of variable A and B to 10 and 15 respectively. So just to notice again here, this is your private member and this is your public member. Now we are writing another definition, get A, which is just going to return me value of A. Okay, so assuming this, we have set the value as 10, so it will return me 10. Now important thing is we are going to write the definition for add function, which belongs to your class addition. I have this variable C which I have declared in the class addition, so I'm using it as is. Then we have one function get underscore A, which belongs to your original class maths. Okay, now we are not writing any object over here because this is directly accessible because we have done the inheritance. Okay, then we are writing plus B. So again B belongs to your class maths, which is of type public. So here it will still have scope as public. And then we have third function, that is display, which belongs to addition. So here we are writing A equal to get underscore A, which is this function, which is just going to return as value of A. So whatever the current value that your object is going to hold, that will be returned over here. Okay, then we are just simply printing B and C. So let us see what happens inside of main function. So we have created object A1 of type class addition. Okay, then I'm calling A1 dot get val function, so which is this function. Okay, so this is going to set value 10 and 15 to A and B respectively, and then we are going to call add function, which belongs to your class addition. Okay, so what is going to happen over here, it is going to return me value of A. We are not directly using A. The reason is it is a private member, so we are going to use it via public member. So here I am going to have value as 10 plus B. Now B is directly accessible because it was public member, so value of B is 15. So C is going to have value stored as 25. Now the compiler is going to call a1.display, which is this function. So it is just going to display value of A, B and C. So again I'm writing get underscore A over here because A is not accessible directly because it is a private member. This particular code will print A equal to 10, on the next line B equal to 15, and on the next line C is equal to 25. After that we are just doing few more things. I am updating value of B with the help of object A1. So A1 dot B equal to 20. What I'm doing is I am overwriting value of B with 20. Just notice that B belongs to your class maths. Okay, but because we have inherited this class, so these members are accessible to my object of type addition. So on the next line, I'm writing a1.add. So again, this function will be called. So we know that value has been updated. So value of a is still 10. So 10 plus updated value is 20. So c will become 30. So this is the new value of c, and again we are calling the same function, that is display. So it is just going to print uh, new values of a, b and c, which is 10, 20 and 30. Okay, and after that my main program is going to end. So here is the output. So once this call is made, this part will be printed, and when we have updated value of 20, so once this call is made, this part will be printed. So this was single inheritance, which was very easy to understand. Now let us move on to the multi-level inheritance. In multi-level inheritance, for the example we have, for this example we have created class vehicle, and we have protected data member, and it is of type int. We are calling it as int underscore id, and then we have our public members. So int b is a public integer, and then we have two functions, get id and put id. So to get id we are passing one integer, and put id is returning us one integer. So we are just going to assume this as our base class, and I'm going to define my function get id, which belongs to vehicle. So to which I'm passing one integer variable a, and I'm just going to set that value into our protected data member of type integer int underscore id. And then the other function put id, it is just going to print the value of int underscore id. Because this is a protected member, it is treated as private, hence it cannot be directly called via an object, but it can be utilized, or it can be called using one member function. In this case we are using get id and put id. So because public data members has access to protected members. So then we have our derived class car. So this is d derived class. So our visibility mode is public, so everything will remain as is. So protected variable will be inherited over here, and those will still remain as protected. So class name of the derived class is vehicle. We are adding one more protected data member into derived class, that is of type float, calling it as version. And then we have two more functions over here which are of type public. The functions are get version and put version. So get version is receiving one value of type float. So when we define the derived class get version, which belongs to class car, I'm passing variable float a to it, and inside of this definition I am storing value of a into variable version, which is protected. It is accessible here because protected members are accessible to your public member functions. Similarly, put version is going to just print this value. So this is the function definition of function put underscore version, which belongs to your class car. And then we have one more derived class d. I'm writing here just for the reference. So show is your derived class, which is inheriting class par under visibility board public. So here we have another variable. This is private because I have not mentioned over anything here. So inside of public scope we have display function, which is not returning or receiving any value. So what is happening in this program is we have one base class vehicle, okay, and then it is being inherited to the class car, and then car is being inherited by new class show. Okay, so all the members of variable will be inherited to car, and all the members from vehicle and car via class car will be inherited to your class show. Okay, so this is multi-level inheritance. Now let us check what happens when we write the main function. I forgot to mention one more function that we have declared over here, display. So here is the definition for the display function. It is just calling these two functions which belong to your class car. Okay, so it is just calling them directly. A reason that it is able to call, because these are public type of member functions, and because there's an inheritance from car to show, these functions are accessible. So inside of main function, I'm declaring s1 as the object of class show. So when I'm writing s1 dot get id, and when I'm passing value as 1, so this function will be called, and value of int id will be set as 1. Okay, and then in the next line, when I'm calling s1 dot get version, passing 1.3 as the value, so this function will be called. So because 1.3 is being passed, so this value will be stored inside of version variable, so version will become 1.3. And then on the next line, we are calling display function, which is this one. So internally this function is calling put underscore id and put underscore version. So if you check definition over here, so put id is going to print vehicle id, and then it is going to print int underscore id, that is 1, and then put version is going to print car version colon, and then value of variable version, that is 1.3. So output of this program is this. Okay, fairly simple to understand. So this is your pictorial presentation, what is happening here. Okay, so once you understand this, so it is just matter of minutes to understand what exactly is happening over here. So whenever the inheritance is being made between these two classes, that is your base class and derived class, so all the members will be inherited to the next class. So once the multi-level inheritance is done, we are moving on to multiple inheritance. Okay, so I'm just trying to simplify things over here. So I have renamed, or I'm using class name as A, B, and C over here. So if you notice, we have one protected member, that is int A, and then we have public function get underscore int, to which we are passing one integer. Okay, then we have another class B, which also has one protected member, that is B, and it has a similar function to a class B, but it is get underscore, to which again we are passing one integer. Okay, so we have class A and B. Okay, then we have class C. Now it is inheriting two classes, A and B, at the same time. Notice that we have used comma operator over here, and for the both classes, the visibility mode is public. Okay, so what is happening here is, so this is your derived class, so A and B are being inherited to C. So inside class definition of C, we have just public scope, and inside it is only single function display, which is not returning any value, or not accepting any values, or we are not passing any values to it. And then we are defining our both functions. So get A, which belongs to A, I'm just passing one value x to it, and x has been assigned to A. Similarly, in function get underscore B, which belongs to your class B, I'm passing integer value y, and which is being stored into variable B. Now important thing is here, so we are writing definition for display function which belongs to C, that is your class here, that is a derived class. So technically these two are becoming here your base classes. Okay, because the inheritance is done now, so what is happening over here is A and B is directly accessible to your class C. So hence data member function display is able to access variable A and B directly. Okay, because the visibility mode was public, so protected members is still going to remain protected in the class C. So just one additional step that we're doing is we are writing C equal to A plus B. So we're just writing addition of variables a and b. So inside your main function, when I create one object c1 of type class c, so I am able to call this function c1 dot get underscore a. I'm passing it the value as 15, so that value will be stored over here, so a will become 15. And also I'm calling function get underscore b, passing value as 16 to it, so b will become 16. And finally I'm calling function c1 dot display, so this part will be executed and it will display a equal to 15, b equal to 16, and c equal to addition of these two numbers, that is 31, and then your program will end. So this is output of this program. So multiple inheritance we have completed. Now we will move on to hierarchical inheritance. In case of hierarchical inheritance, what we have done is we have created one class calling it as maths. Then we have two integer variable with the scope as public, and then we have one function to which we are passing two integer values, calling this function as get underscore val. And then I'm writing definition for this same function get underscore val, to which I'm passing integer x and y. So once these values are passed, I'm just storing those value into a and b respectively. Then I'm writing two more classes, one is addition and other one is multiplication. Both are inheriting class maths with the visibility mode as public. So you can check here, maths and visibility mode public. They both have one function, add and mul, that is multiplication respectively, and it is just going to perform addition operation on variables a and b. Now notice that a and b are again directly accessible because we have inherited these values from class maths. So what is happening is maths is your base class, okay, and then it is being inherited into your other class, that is addition, okay, which is your derived class, okay, and then we have one more inheritance, that is for your class multiplication, okay. So this is hierarchical inheritance that is being performed because of these two type of classes definition that we have wrote here. So similar to add function, we have mul function where we are just performing multiplication, okay. Now inside of your main function, we have created object of type class addition, and we are calling it as a1, and other object m1 which is of type class multiplication. So using object a1, we are calling function get underscore val, to which we are passing values at, and then we are performing operation add, okay. So when this 15 and 16 as values are passed via your function get underscore val, so what is happening is values of a and b which somehow now relate, which are now associated with your object a1. So a1 dot a becomes 15 and a1 dot b becomes 16. So once this add function is called, it is just going to execute this particular lines, and it is going to print a plus b is equal to addition of a and b. So a and b is 15 and 16, so we are going to get over here a plus b equal to 31. And then on the next line we have m1 dot get underscore val, again we are passing 15 and 16 as values to it. So again this particular function will be called, and values of a and b will be updated with 15 and 16. But now notice that earlier we have called a1 dot a and a1 dot b. Here we are talking about a1 dot a 15, and we're talking about m1 dot a equal to 15 and m1 dot b equal to 16. So m1 and a1 are holding different set of values a and b. Now once this initialization is done using function get underscore val, I am just calling m1 dot mul, so which is just going to print a multiplication value of a star b, okay. And after that the program will end. So output of this program is this. So a plus b is 31 and a multiplied by b is equal to 240. So this was hierarchical inheritance, and now we are going to learn about hybrid inheritance. So we have our class maths with public data member as int a, then we have a derived class then we have a derived class B, which is inheriting maths with visibility mode public, and we have one public function calling it as B. We are just assigning value 20 to variable A. Now A is directly accessible because it's a state inheritance. I'm uh, inheriting public members int A with visibility mode A. So A would be directly accessible to me, and whenever an object of class B is created, variable A will also be created. Okay. Now we have one more class, that is class C. Okay. It has a separate variable B which belongs to the class C, and then we have one function C which is initializing value of B to 10. And after that we have one more class sum, which is inheriting two different classes B and C with visibility mode as public, and it has one function called as sum, which is going to display me value of A and B. Now let us try to understand this via one diagram, because we are talking about four classes over here. So initially we had our class maths, okay, which is your base class. Then class B is inheriting class maths. Okay, so I'm writing B over here. So this inheritance is done. Then we have one independent class C, okay, which is technically a base class again. Okay, so this is your base class, this is your base class, this is a derived class, and even your class sum is a derived class. So why? Because sum is inheriting two classes B and C. Okay, if you check here, sum is inheriting B and C. Okay, so this is the type of inheriting that is happening over here. Okay, so maths being your base class, B is inheriting it, and C is another base class which sum is inheriting along with the your existing derived class B. Okay, so this type of inheritance is a hybrid because we are using multiple as well as multi-level inheritance in it. Now because this is done, so when I'm saying A and B which belongs to class C and A, okay, so class C has B and class maths has A. So if you just take A and B are still going to accessible in class sum. Okay, so that is why when I create object s1 of type sum, so s1 dot sum can directly be called because this function is part of your class sum, so there's no any problem. But inside of function sum, I am referring A and B directly because those are inherited now, so we can use them directly. Now whenever a class object is created, these functions will be called automatically. Why? Because these are constructor. If you check the class name and function name over here, so these are constructions, same name, so hence this will be called by default. Okay, so when this line is executed, so some s1 will be executed, so s1's constructors will be called. But because these values are relying on its base class, so these constructors will also be called. You might have a question that which constructor will be called first. So obviously the constructor of your base class will be called first, and then constructor of your derived class will be called. So once this declaration is done, uh, because we have done inheritance here of B and C, so this constructor will be called first, so value of A will become 20. Then this constructor will be called, so value of B will become 10, and after that this constructor will be called, so sum will be equal to A plus B, that is 20 and 10, so 20 plus 10 is equal to 30. So this constructor is, so there is one more important point to notice over here, that this is not a constructor, this is just a member function. Because if you just notice, this S is in caps and this S is in small. Okay, so this is not a constructor, this is a normal function. That is why we have called it as s1 dot sum sum in small. So this is a normal member function. Okay, But anyways, the point that I'm trying to make over here is that though I have created object of s1 over here, the constructor of your base class are called automatically. Okay, so output of this program is sum equal to 30. Okay, now one important point that I want to make over here is, let's say you extend this as well. Okay, so let us assume that your class C is also inheriting class maths. Now the problem here is that A will be inherited here as well. Okay, so A will come here, and because of this inheritance A will come here as well. Now when this multiple inheritance will be done for your class C, whenever one object is instantiated, you will have two different version of variable A. So for a compiler, this is one ambiguity. Okay, now to tackle this, there's a provision in C++, and we call it as virtual base class. Okay, so what happens in virtual base class is you have your class math, then two public data members A and B, and we have one function which is just going to print value of A and B. Then you have a class B, and I'm writing virtual public math. So math being my base class, I give access to the new derived class B to make it a virtual base class. Okay, so class B becomes your virtual base class. So syntax is virtual keyword that you can add either before public or after keyword public. So you can write virtual public math, or you can write public virtual math. So both are allowed in C++. Now inside a public scope, we are writing get underscore a as a function to which I'm passing one integer variable, and I'm just going to update value of a. Okay, so which technically belongs to your class math. And then we have another class, class C. Again, I'm mentioning word virtual, so virtual public math. So this also becomes your virtual base class. It just has one function get underscore b to which we are passing integer value y, and y is being stored into b. B is directly accessible over here because of this inheritance. Okay, so after doing this, what is happening here is we have this base class math. Okay, then we have done the inheritance to b and inheritance to c, but because we have added this keyword virtual now, so these two also become your virtual base class. Okay, now if you just notice over here, class D, I am just doing the inheritance with class B and class C. So this is my new class D. Okay, so this is my multiple inheritance. Okay, now because the variables are coming via these two modes over here, so in the previous case it would have given an ambiguity to the compiler. All right, so because we have made B and C as the virtual class, you can completely ignore this part just for the time's sake. So you can just assume that these are two different variables over here, these are two different classes over here. So to the compiler it becomes a virtual class, and it is just going to assume a single copy of the common variables. So inside of main function, what is happening is we have created one object d1 of type class D. So d1 dot get underscore a, it will initialize value of your variable a to 10. Similarly, the next line will initialize value of b to 20, and then we are just calling function show, which belongs to your class math, and it is just going to print value of a and b, which is 10 and 20, and after that your program will end. So things to notice over here is that a and b, though it belonged to uh, class math, and because this math was inherited by both variables b and c, and B and C, which are still extended or which have got inherited to variable D, no duplicate copies are made over here, only single copy is retained because B and C are treated as virtual base classes over here. So very important topic, virtual base classes. So that is all for this video, guys. In case you like this video, do give it a thumbs up, it will really encourage us, and don't forget to share this video with your friends. In case you are not subscribed to our channel, do subscribe and also hit the bell icon so you get the instant notification whenever we upload a new video. I will see you in the next video, which will be our module 8. Thank you so much for watching this video, guys. Enjoy.